Now, before I start, let me just make one thing very clear. This is not a TED talk or a lecture. I'm just going to be sharing like how I navigated research with a bit of a luck and a lot of what am I even doing moments. Yeah, so I think we'll get started. Now, again, a quick disclaimer, I might drop in a lot of anecdotes. I just love storytelling, so please bear with me. But about how I got started with data science, well, I have liked coding even when I was in school actually. So I had like Java in my ninth and 10th grade. So I had a little bit of basics to coding and computer science in general. But in my 11th and 12th, I was actually in the bio stream. So I had lost all touch when I came to IISER. And when I had joined IISER, I had in mind chemistry or biology. Like data science was not even on my mind. But 1 year into IISER, I was pretty sure that chemistry is definitely not my thing. So at this point, it was either data science or biology. And the thing that made me choose data science over biology was the fact that the only assignments that I put an effort into doing were the IDC assignments. So I figured data science will be the right decision, and it was. So yeah, once I had chosen data science, then came the courseworks, right? Now I had actually severely underestimated the amount of math that we will have to do. And there was a lot of math even in the first semester. We would have like discrete math, optimization techniques, and so much math. Even in ML, there was a lot of math going on. It was hard, but like we would have these group sessions, study sessions just before the exam, and like teach each other stuff, and we made it. We made it alive. Now I thought I'll put here some of the courses that I felt were important, and like I wish I had paid more attention to these courses. Now, data structures, obviously, you ask anybody, any data science or computer science major, they're going to tell you, like, know your data structures. Because even if you go for any job interviews or any internships or just a coding test, anything, they are going to question your data structures basics. You need to know your linked list and stacks and queues. You need to be clear on those. And another like course is design and analysis of algorithm, which is quite underrated actually. But these dynamic programming and like greedy algorithm and that stuff also, you will find yourself actually learning, reading about it at some point of time when you're doing your project. So I think these two courses are like the most important, according to me at least. And of course, there is ML. And in ML, I would say that rather than like just learning the names of some models and knowing what they do, and just rather than making it theory based, it would be good even to start with the math behind the concepts, like what is back propagation, like how what is the math behind back propagation, and why the gradient descent algorithm works, stuff like that. You will have to know the math behind it if you are even going to make it. Like if you want to build a model and train it, you need to know what goes on behind it, right? So you have to pay attention to that. And obviously statistics and parallel computing, again, at some point of time you will find yourself wanting to know these topics. And DBMS, it really depends on what field you go in. It might or might not be important, but if you were to give like exams like gate or net, there would be a lot of questions from DBMS and like SQL queries. So these are the courseworks. uh, Now, I wanted to talk a little bit about how I got started with research, because courseworks, they are given to you, right? You don't have to worry about those. But getting started with research is not like that. You will have to figure stuff out on your own. So for me, at least, it was like bird box, because we didn't know what we were getting into, because we were like the first batch that had data science as a major option. So which meant that there was like not properly established department yet, not many professors, and no real seniors to turn to or ask help from. Of course, we had like math majors and physics majors who had taken data science as a minor, but it was I mean, you get it, right? Like it's not the same. So it was difficult to start. And another thing was, when I started out, I didn't have like fixed interest. As I mentioned, I was even confused if I have to go for bio or data science. So when I started out, I knew that I somehow wanted to connect whatever I'm doing with biology, but I didn't know how. Everything was exciting, but I just didn't know where to start. And to get internships, I wanted to do internships, right? Everybody does. Like, there is peer pressure and you want to do a lot of internships. So I actually started off by cold mails, of course. So I would be like writing 10, 15 mails to professors I find. And of course, most of them got ignored. I would get like one reply to like 10, 15 emails, not even that, one to like 50 emails. And I mean, in the beginning, it was heartbreaking, but at one point, you just get used to it. And I personally felt that if you put in the effort to write the mail, then it really shows. Like, you do some background research on the professor, you know what his interests are, like you read some of his papers, and maybe mention like how you could contribute to his work, and that shows the professor that you put in the effort. And like, I mean, today everybody uses ChatGPT to write mails, and it's quite obvious that you used it. So you have to like customize it, personalize it for every professor that you write it to. Now, I did get a reply to a couple of emails, and I ended up doing a couple of internships. So first was with this data scientist from the math company, Shrish Mishra, who this was more like a mentorship than an internship, because I would like he would ask me to learn stuff. He would send me these YouTube playlists and articles and papers to read, and it was just about me learning stuff rather than doing some groundbreaking research. I mean, we would have these weekly update meeting where I would tell him what I learned in the week. He'd ask me to summarize what I had learned. And uh, this is the time where I started learning doing things from scratch. So it was a very good starting point for me, because I implemented backpropagation from scratch. So I learned to use like PyTorch, and like I implemented a couple of LLMs. I started off small in this time. And one very valuable advice he had given me was about writing blogs. So when you actually learn something new, when you try to do something new, you feel that, like, when you learn something, you watched a video or you read some articles, you feel that you know stuff, you feel like you understood it clearly. But it is when you try and explain it to somebody else, that is when you realize that you didn't quite grasp the concept, right? There might be still black holes that you didn't explore. So I personally felt like writing these summaries or like articles helped me understand where I was lacking. And also it would be a very good way to revise later when you want to come back to the concept. uh, then after that, I had done an internship at NIT Calicut with Professor Sudesh. So this was again through cold mailing. I had at this point of time, I wanted to explore something called the vision transformers, which is where you incorporate transformer modules into like computer vision models. So I had mailed him that I wanted to try and learn about vision transformers. So he had shared with me some papers and asked me what I'm interested in, and I said I would like to explore MR reconstruction. So actually, unsupervised MR reconstruction, I started off with a paper called Slater, and it was quite a bit of challenge because I haven't yet explored medical imaging yet, and doing unsupervised reconstruction from the get go was quite challenging. But most of the work, it was a 3 months internship, and most of the work was like about reading and understanding, because I was getting started. I had to like understand the MR physics, and how unsupervised reconstruction is generally performed, stuff like that. And these are a bunch of lessons that I learned during my time there. uh, as much as important as it is to write your own code, I felt that it is equally important to be able to like use other resources, like use the tool smartly. You knowing how to Google smartly or get the accurate answer to what you're searching for, that is equally important. And also, you should know to like read GitHub issues and understand somebody else's code base, implement it. These are all very essential survival toolkits when it comes to this field. And of course, progress is not at all linear. So one day you'd get like really good results, and then next 2 days you would be stuck in an error. It happens. That's research, right? So I mean, during my time at NIT, I remember like this. There was this one code. So I had like this. The professor had assigned me to a PhD student, one of his PhD students, and both the professor and the PhD student, they were like really nice and very helpful. They were like open to answering any questions I had. They were basically very nice people. So this one time we were trying to implement the code base of Slater, and we just got stuck. And we were stuck there for like 3 full days. Anything we do, we just couldn't get over it, because I mean, I would come in the morning and search the internet for all possible solutions, and I would implement it, and nothing would work. And then my PhD guy would come, and he would try all the solutions he has in mind, and nothing would work. But end of the day, it was like some minor mistake going on with the environment. And when we figured it out, it was just pure bliss. So that is what you get, that happiness. You're stuck in one place for 3 days, and when you figure it out, you have that like feeling of satisfaction. That is like irreplaceable. And another very good advice that my PhD had given me was about taking online courses. So this is like you do it on your own, right? There's no pressure. There's nobody asking you to do this. So he had asked me to do these Coursera courses because you could get them for free essentially. You could apply for financial aids and you don't even have to pay for these. I had actually signed up for these IBM professional certification course for full stack development. And guess what? Next summer, I ended up in IBM Research. So about my IBM Research experience. So the application process was like it was just like any other job application. So I had one random weekend, I was having an existential crisis. I think it was late August, and I didn't know what I was doing with my life. Like I didn't know where I was going. So everybody was like having super cool internships, and super were already like had done 3 4 internships. And it was, the peer pressure, it is very very real. So I had done at that point, I was going on like a rampage of applications, and I had come across this IBM careers portal, and they had like this AI research intern position open. So I just applied and completely forgot about it. And then like a month later, I got a mail saying I had passed the initial screening and will have to take a coding test. Now the coding test, it was total of 90 minutes, and I had to take it like I had to attend 2 questions, 45 minutes each. The questions were basically like testing your problem solving skill and CS fundamentals, a bit of data structures. It was like these questions you can find in lead code, a little bit advanced. um, so I had passed the coding test. I did fairly well. And then like a week later, I got a call from the HR saying that I had passed the coding test, and I'll have a discussion scheduled with one of the mentors. So the first interview was with someone called Aaqilah, and she had actually asked me a bunch of technical questions, and mostly about my works, my past research experience, my past projects, and stuff like that. And then once that was done, I had another interview scheduled, and this was with someone called Prince. And this was again about a little bit checking my technical understanding, and then a little bit about my projects. And in fact, he had actually asked me to share my screen and do live coding. But yeah, once that was done, uh, I did okay. I mean, I was not very proud of the way I performed in the interviews, but I was trying to not get my hopes up high. But anyways, long story short, I just made it. I got into IBM Research. And so once I went there, once I joined IBM, I was a part of the hybrid cloud team. And the project I worked on was in 2 parts. So like the first part was where I would like compare and contrast these distributed training frameworks like FSTP and DeepSpeed. So these are, FSTP is fully sharded data parallelism. So these are like the frameworks that you use for scaling model in distributed training manner. And my my work was to, so these frameworks will actually have these configuration knobs that you could tune. You could set it to values, like for example, turn on or off, mixed precision, or like how to wrap the model into smaller modules, stuff like that. You could manually set values to these configurations, right? And so my work was to understand, like compare and understand the effect of these modules while on the entire model's training time. And that was the first part. And the second part was about auto detecting the configurations during the runtime. So what happens is, when you train a model, you set these configurations to a particular value, but and you expect a particular result, right? But more often than not, you don't get the result that you expect. Like sometimes you expect the runtime to go down, but the runtime might actually increase. So you don't know what is actually going on. You end up like worrying if you didn't set the configurations correctly. So for that, we had come up with like an auto detection framework that would give you the configuration setting from the runtime, while the runtime is happening. So that we did by using PyTorch hooks. So that was the project I worked on. Now, to talk a little bit about my experience over there, like overall experience. So I was transitioning from, so far I didn't have an industry experience. This was my first industry experience, right? Of course, it was challenging. It was a completely new domain. I hadn't worked with systems so far. So it was my first time, right? And it was quite challenging. Everything, it was very competitive. The pace felt faster, but like at one point I was like trying to figure it all out on my own. Like I would have like task assigned to me, and I would like hesitate to ask for help. And but it was super important to ask for feedbacks and like ask questions. It is like super fine to ask questions, and let people know that you don't know this stuff. It's okay, because you can always learn something. It's fine to let ask for help and ask questions and learn. And also, another thing I struggled with is communicating updates. So we would have like weekly meetings to update our progress on that particular week. And sometimes you don't have results. Like you have one good week, and next week might not be as good. Like when you have good week, it's fine, you could present the results. But when you're stuck somewhere, you don't have result. Then I like personally struggle with updating, like where I was stuck and what I had done. But it is super important to even be able to like update people when you're stuck somewhere. You can tell them like what and all you try to do and what worked and what didn't, stuff like that. And also industry really values initiative, because the little effort that you put in to read something extra or maybe trying something out on your own, that really shows that really puts you apart, like it makes you stand out. uh, yeah, so these were some of my takeaways from my experience at IBM Research. uh, Now moving on to my master thesis, I would like to like make a quick summary of what I did during my master thesis. So I worked on, as I mentioned, I had actually interned at NIT Calicut, which was on MR reconstruction, and then I had done work on IBM Research, which was on the system side. While I did enjoy my work that I did in IBM, I figured that my liking was more towards MR, like medical imaging or MR reconstruction. So I joined the CIDS lab under Dr. Raji Susan, and she asked me if I would like to work on QSM reconstruction, which is quantitative susceptibility mapping. So it is like an MRI based technique that helps you quantify magnetic susceptibility values of tissues. Now, what is susceptibility? Well, essentially, when you take an object and place it in a magnetic field, it gets magnetized. Now, you could quantify the extent to which the item is magnetized. Now that quantification, that value is what you call susceptibility. Now it could help you differentiate like substances based on their magnetic properties, say like iron and calcium. So that the whole process of identifying susceptibility from MR acquisition is called QSM. So Essentially, QSM involves four steps. So first you have the MR acquisition. So you get the MR data and you do a bunch of processing, like you perform face unwrapping and background field removal. So this is like isolating the field of interest. So once you do that, you have something called the local field. Now from this, you have to extract susceptibility. That step you call dipole inversion. So here this delta over here is the local field and chi is the susceptibility. And to get chi from delta, you'd have to take the inverse of D, dipole inversion. So, but the issue is that there are some points in K space where this dipole kernel tends to zero. So in such points, what happens? The whole entire problem becomes ill posed. And when you stick to like traditional approaches, you either end up with suboptimal results, or you have to use more computation. It becomes computationally intensive. So of course deep learning has been used like an alternative for this entire problem. And in my first phase, what I did was I was just getting started, right? So I used like a supervised training approach. Now for those of you that don't know supervised and unsupervised learning, so machine learning, you can either do it in a supervised manner or an unsupervised manner. So in supervised manner, what you do is you give A as the input to the model and you get B, but you have the data A and B mapped, like you have the labeled data A and B. So you train the model using some loss function like mean squared error, and you try and map A and B. But in unsupervised learning, you essentially have only A and you don't have B. B is not in picture. So you'll have to teach the model to get B out of A even without any prior data. So yeah. So in my first phase, I had used a variational autoencoder to perform supervised learning, but we hypothesized that given the probabilistic framework of variational autoencoders, we would be getting like a more generalizability in the model, and also the model should be able to perform better in a limited data setting because the model was learning uh, the distribution instead of like direct mapping. But in my second phase, I wanted to explore something more challenging. So I took up unsupervised learning. Now, as I mentioned, unsupervised learning is when you don't have labeled data. So we have the input MR acquisition, like local field. So I used a unit based architecture, just a normal unit, and I performed training using a loss function that was derived from the dipole convolution. So I essentially incorporated this particular equation into the loss function, and the model learns this relation and is able to output the susceptibility. But what happens, you don't essentially get good results. So for that, we tried out test time adaptation. Now generally in medical imaging, what happens is you are in shortage of data, you are in shortage of good quality data. So we perform patch-wise training where we perform the entire volume into smaller patches and use it as training samples. So the pre-training was performed the training was performed using these patches. And then when it comes to test time, usually while we are using a model, we only train it, like we only update the weights during the training phase, right? During testing, the weights are all fixed and we only use it for inference. But in test time adaptation, we actually update the weights even during the test time for a few iteration. Of course, the computation is a little higher, but it is, I mean, it is always like a trade-off between computation and performance, right? But you try to balance the both. So we have an additional refinement head attached to the unit, and we update the weights of this particular refinement head during the test time. And this we do again using either the dipole loss or something called TKD loss, which is another equation. And and what happens is when, and here during test time, we actually update the weights using full volumes instead of smaller patches. And again, what happens is after a certain point of time, when you update the weights, the model starts to overfit to the noise in the data. So to prevent that, we used a stopping criteria. That for that we use something called SURE. SURE is Chain's unbiased risk estimate, which is an unbiased estimate of MSE or mean squared error. So MSE is actually the mean squared error between the predicted value and the ground truth value. So sure could give us the estimate of MSE even without the ground truth. So what so after every iteration we would check the sure estimate, which is essentially like an approximate estimate of MSE. And if the sure is once the sure starts increasing, we know that the model is starting to overfit to noise. So that we will consider as a stopping criteria and take the final output. So that is what I did in my master thesis phase 2. So these are the results that we obtained. So generally for medical imaging or particularly QSM, we use four performance metrics: SSIM, structural similarity index, and PSNR, which is signal to noise ratio, and NMSE, normalized mean squared error, and HFPN, which is high frequency error no. And we compared it with the traditional approaches that are available for QSM, and we found that our model performed better. So these like I got a chance to present my work in phase 1 at the ISMRM conference, which was hosted at IIT Hyderabad. So ISMRM is like this big conference for MRI reconstruction, I mean MRI. So yeah, that has been my research journey so far. Now before I wrap up, I just wanted to talk a little bit about what actually worked for me and what didn't. Like oh wait, yeah. So one of the biggest challenges I had to deal with, and honestly, sometimes I still do, is imposter syndrome. So whether it was while at IBM or whenever I start a new project or when I join a new team, I often find myself feeling like underqualified or like I don't know enough or enough to fit in, that sort of feeling. But over time, I've learned like this feeling is more common than we think, and for me at least the key to overcoming this was like acceptance. I mean, it is completely fine to not know stuff. I mean, in this day and age, you have access to all the resources. You have chat gpt and google, and like everything is one click away, so you could learn anything overnight. So it is not it is definite completely okay to like not know stuff. And yeah, and another thing that I found myself doing is trying to prove myself immediately. Like even when I was at IBM, I was like, even at the beginning I was trying to prove myself like that I can do stuff, and that actually it's ended up burning me out a little. And once I start shifted the focus from being impressive to like being genuinely curious, things actually fell in perspective. It really helped with my progress moving forward. And asking questions, it is not like you of course you're going to struggle when you start something new. Of course you're going to struggle, but it is okay to ask for help. You don't have to struggle alone. Definitely ask for help. And one other thing that I had found helpful was keeping track of the small wins. So, as I mentioned, research is going to be, you're going to have good results one day, and the next 2 days are going to be hard. So, in the bad days, if you have something to look back at and be proud of, that is really going to help you. So, keep track of the small wins, write it down, and like have something to be proud of later. Um, and finally, this, I still struggle with this honestly. Avoiding speaking up in meetings and asking questions. Like I just always assume that my questions are very basic, like it is not worth asking. But it just start asking questions. I cannot stress this enough. But like the more questions you ask, the faster your progress is going to be. So yeah, that is all I've got. I hope this presentation gave you some clarity or at least some comfort that we are all figuring things out as we go. So, yeah, you can ask me if you have any questions.
Thank you very much, Akila, for this wonderful.
Yeah, thank you so much, Coding Club, for having me.
Thank you so much, Akila, for this wonderful talk. I really enjoyed it. And if anyone has doubts, okay, I would like to start from myself only. So I am also a biology student, and I'm also looking for things in data science and especially neuroscience, which is also your field. So how was that transition for you to like go from as a bio student to go into data science? And you said you didn't had maths in like 11th and 12th, right? So how was that experience about learning maths, and just how was the overall shift for you?
Uh, to be very honest, it was very difficult because at one point the first 2 years, the first year particularly, we had it online, right? So we were just messing around. We were not really very serious doing and math and all. We just did it to pass and get like passing grades. So when the time came, after choosing data science, you have to know certain math. You have to put in an effort and learn a little, right? But what helped was like everybody in our batch was like very helpful to each other. So if I know something, I would teach it to someone, and if they know something, we would have like these discussion session where we would teach each other, and that is what really helped at least me pass exams. um, but I think you could manage. End of the day, it is not like hardcore math. You're not going to be doing theorems and proofs, like not that math, but more logic based math. And that, I mean, logic, it comes from within, right? So if you're going to do coding, you have this logic. The same thing, the same sort of math is what you're going to need for data science. So and going from biology, for me, actually, it was going to MRI, right? So it was more physics rather than biology. I was learning more about physics. So of course, it was a little bit of a learning curve, but I started off with like videos, YouTube videos. Actually, many playlists are very helpful. Like I personally prefer starting off with videos rather than reading, and then I move on to reading because then you understand the paper better. Any articles, rather than like straight off going to the article, I have personally felt that when you start watching a video, you understand things better, and then when you go to the article, things like fall in place. So yeah, you take some time. You could it could be a month or a week, but it really depends on what phase you're comfortable with.
Thank you for the answer, Akila. Also, we have a question from Kirtana about timeline of your internship.
Huh. So, as I mentioned, the first 2 years I was confused if I had to go for bio or data science. So the first, for this by the end of the first year was online, right? So there was no scope for internship. And in the second year, I had actually joined Dr. Sandhya Ganeshan's lab for a biology internship, and I had in fact started reading papers and attending meetings. But then the form for choosing major came, and then I had chosen data science. So I mentioned to ma'am that like I've chosen data science, and I would also like to do like data science internship because that would be more useful, right? Starting off. So, but ma'am was like, she was so sweet. She was like, you could always come back, but right now I think you don't have like don't try out multiple stuff at one time. Do like focus on one thing. So I went and met Dr. Devraj, like from the math department, and he had like given me this book to read and asked me to explain stuff. So that was, I wouldn't call like it wasn't a proper internship, more like a study, like more like to study. It was a session to study, and that was the first time. And then in the third year, that was in second year, and in third year winter, that is when I met this Trish Mishra. Like I found him, I'd mailed him. So that was then. And then in fourth year, no, third year summer, I had this internship at NIT Calicut. And fourth year summer, I did an internship at IBM Research.
Thank you, Akila. Also, do anyone else have any doubts or questions? They can turn on their mic also, or in call messages also they can send.
Uh, Hello, Akila. The
Hi.
the talk was really beautiful. Like the last session, I enjoyed too much. My question was about your like internship experiences. Since you have experienced both academic and industry, how would you compare the two in terms of goals and limitations? More specifically, what constraint do you see in academic research versus industrial research?
Well, for me at least, the main difference would be how competitive the industry internship was, because you're put there in a pool with like top IITians and like from all over India, people are there. So you have this inherent need to prove yourself. But in academic, it is more about you can do it at your own pace. I mean, of course, it depends on the professor you do it with. At least mine so far has been about prioritizing what I need to learn and like how I can progress at my own pace. It had been fine. So that is what yeah, that is what I felt was the main difference. Other than that, about goals, of course, in the industry there is going to be this fixed goal because you're working on a project with a team. So your progress might affect the team's progress. So it is going to be a little bit more pressure. I mean, don't get me wrong, my team was like super cool. Like the manager, the mentor, everybody was super cool. So they were very helpful. Every time I had a doubt, they wouldn't like they know that we're like undergraduates, so we would be struggling with stuff, and they were like always keen to help. So yeah.
Uh, Thank you for the like beautiful answer. One more thing I want to ask that you mentioned doing the IBM professional certification. Did
Yeah.
did that help you get into IBM research? Like,
Honestly, I don't know. It could have, it couldn't have. I put it in my CV, so I don't know if it helped me pass my initial screening. Because I mean, up until then, I didn't have much of a internship experience. I had this like this mentorship, and then it was medical imaging, right? But the one I had applied to was like LLMs based. So I don't know if it really helped. But I think it does show that you're willing to learn and you're willing to put an extra effort. I think it could make you stand out.
got it. Thank you, Akela. There's some question from Satyam. Chance, can you read it in chat?
Yeah, from Satyam, we have question: Is there are there PhD opportunities in data science? Okay, or getting into tech companies where we have more exposure. So, if you can explain
So,
more about.
yeah. So, tech companies, it really depends on what sort of roles you're looking for. If you're looking for like software roles or like data analyst roles, then I think you have a lot more opportunities in the tech field. But if you are looking for research roles, like if you want to get into just R&Ds, then the entire process is as competitive as it is for PhD. The opportunities are pretty much equal, I would say. And it also depends on what field you are looking for. So I know for medical imaging, at least we have options like GE Healthcare, Siemens is there. But you often, like if you want to go into R&Ds, I think generally a PhD is preferred. If I mean, you don't get me wrong, you could still get into the R&D roles with an master degree, but I think a PhD could help you get into a tech role as well. So yeah, it depends on what sort of roles you want to get into. Should I go for a PhD? If you want to be a researcher, yeah, I would say you should go for a PhD. It could help you like get the skills because I did like in IBM Research, right? So it was also like the R&D, and I found myself like want having lacking in so many skills. Like I've had so much to learn, and right now I am actually going for a PhD because I felt that there is so much left to learn for me personally. So yeah, I think if you have to be a good researcher, it is not essential. I mean, it is not a necessity, but it is personal preference, I think.
Any other doubt from the audience? Kirtana, I have some doubt. Akila, can you read?
Yeah. So can a research student like us be at par with engineering undergrads to write the GRE GATE exams? If there's any materials we could make use of to come to that level. Yeah, of course. I mean, you could take the GATE exam, and even I passed, I qualified gate, and I didn't even prepare. I did it just with the data science courses that we had. So it is, you can still qualify gate, I think, with the course that is being offered for us. So for any materials, I am not really aware, but I know there are a lot of courses online, like even on YouTube. I think there are a lot of gate preparation modules. I've seen my friends take it, so I could ask them and share it with you if you want.
Also, Akila, I had one doubt, not a doubt, just your opinion. So recently, I've
Mm-hmm.
seen big tech companies like Google and Meta are researching more about biology. I've seen many papers coming about AI research connected with like neuroscience or many things related to biology. So, do you think there will be like a growth in industry about research mainly related to biology and AI? Do you have any opinion on that?
Yes, definitely, definitely. I think people. Neuroscience is an ever-growing field, I feel. So, of course, industries are going to lean more towards whatever is on demand right then. So, yes, I feel there would be an increase of opportunities for anybody that is willing to pursue this, I think.
Thank you for answering my question. Also, do we have any other questions from the audience? We still have time.
Oh, thank you so much, Kirtana.
So I guess we'll conclude the session. Thank you so much, Akila. It was a very interesting talk. Generally, I'm not interested in talks, and this is for me personally. I find them boring, but this was very amazing. It was very interesting to learn about your experiences. So thank you for joining us, and thank you for letting Coding Club host you. And
Uh,
it was a very nice talk, and
Shreyans,
we'll see you again in future. Yes, Saurabh.
hello. Akila, I want to ask you something. Like, it's a little
Yeah,
bit of
sure.
technical. Since you have worked with both
Mm-hmm.
LLMs and neuroscience, do you think LLMs are truly
Mm-hmm.
capable of thinking in any meaningful way? And do you see potential in integrating insights from neuroscience to improve or, say, evolve LLM architectures?
I'm not sure about like using neuroscience to do LLMs, but of course, modules from LLMs, like concepts from LLMs, are like super. But it has so much potential to be integrated into neuroscience, though. Like for example, as I mentioned, I had personally worked with vision transformers, and I know that like. These transformer modules, these attention blocks that have like that has so much potential, because you could use it to like enhance the local and global context, and for better, just a better understanding of even across images, you could learn the relations between the pixels. And these transformer units are like, it has so much potential. So I think transformers and neuroscience, it could go well, so much. It could go well so together, I feel.
Thanks. That's all. Can't agree much. Like, it's okay.
Thank you again, Akila. We'll have a group photo, so if everyone can turn on their cameras. So thank you everyone for joining this talk. Thank you again, Aaqilah. It was very wonderful talk. We enjoyed it very much, and we are hoping to see you more in Coding Club. As I've seen in the last slide, you have a Medium account, so maybe we can have blogs from you. We have a blog section in Coding Club website now, and we are constantly trying to upgrade it. So, yeah, thank you very much for
Yeah.
joining us.
Sure. Thank you so much. Thank you so much to Coding Club for making this happen. And thank you everybody for listening. I mean, if you ever want to rant about research or just talk, you can always contact, like drop a mail or like connect with me in LinkedIn. Yeah. Thank you so
Thank
much.
you. Yeah, thank you everyone for joining us for this talk, and we'll conclude the meeting. Thank you.
Yeah. Bye.
Bye bye.
Bye bye.